Thank you so much. So for thousands of years, for most part of our human history, the biggest threat to human health were these diseases. And what is amazing now is nearly half of you may not even recognize these names of this disease, or may not even know anyone who had this disease in their life. So what happened? What was the magic? What was the common glue that helped us to fight this disease? And I think almost 200 years ago, there was a simple theory called the germ theory of disease that essentially had a very simple idea that these diseases are caused by pathogens who live outside our body, and somehow they get into us and then cause disease and kill us. That simple idea drove three foundations of modern healthcare, and that's sanitation, vaccination, and antibiotics. And this revolution started almost 110 years ago, when life expectancy for a baby born in this country was around 42 to 45 years. And every single year of biomedical research in the last 100 years has added 3 months to human health, human lifespan. So now in 2018, if a baby is born, he or she is expected to live up to the age of 80. And that was the miracle of a simple theory. But now, although we live a very long life, half of our life is spent fighting with a lot of these different diseases. So although we live long, we don't live healthy. And these are very diverse type of disease. So then the question is, can we think of a very simple idea, just like the germ theory of disease, to fight and effectively manage, reverse, or even cure some of these diseases? And so in that context, I want to give you a very revolutionary and profound idea that many of these diseases may be due to disruption of what we call circadian rhythm. So the word circadian comes from two Latin words, circa, nearly, and dian means 24 hours. So that means these are 24-hour rhythms. So then the question is, why do we have these rhythms? And the reason is, ever since life thrived on this planet, all life forms on this planet have to adapt to this very predictable change in light and darkness every single day, in every 24 hours. So that's why every life form has evolved to have these rhythms encoded in their DNA. And it's so intrinsic to all the life forms that if we take human, plants, or animals from our planet and transfer to another planet that has the same identical ecosystem, but if the day-night cycle is other than 24 hours, then we cannot survive and thrive. And in recognition of this foundational, fundamental impact of circadian rhythm in health and life, last year's Nobel Prize was given to 3 leading scientists in this field. So then the question is, how do we know that we have a clock that keeps 24 hours rhythm? A very simple experiment you can do is you can lock me in this room with enough access to a bed maybe and some food. And what will happen is, although I won't have any access to timing, I would go to sleep around 10 o'clock at night. My deepest sleep will happen around 2 o'clock. Even without an alarm clock, my body temperature will begin to rise 2 hours before the sunrise time. And then as soon as I wake up, open my eyes, my sleep hormone melatonin will begin to plummet, and my stress hormone cortisol will begin to rise. And bowel movement will be most likely in the first half of the day. My body will be most effective in digesting food, a better insulin sensitivity in the first half of the day. Then as the day goes on, my brain will be at its peak performance around noon, and then right around this time, my muscle will be at peak performance. And then as the evening rolls in, just like clockwork, melatonin will begin to rise, body will cool down, and I'll go back to sleep. And this will happen every single day. Even if you lock me here for a year or two, this will continue to happen. And this happens because almost every single hormone, every brain chemical, and even every single gene in our genome is programmed to rise and fall at predictable time. And all of these give rise to one simple phenomena, that is, we know that there are three foundations of health: sleep, nutrition, and physical activity. In fact, all of these are directly or indirectly regulated by this timing system. And I think this is the most complicated slide, because what I meant to say is these clocks regulate when we sleep, when our body is most effective in digesting and absorbing nutrition, and then when our muscle is most effective in doing exercise. At the same time, these three are under its own regulation. So although the clock tells us that our body is most effective in eating at a certain time, if we don't have access to food, then we'll feel hungry. So similarly, these three systems are regulated within themselves, and they affect each other. And then this whole system is linked to the outside light-dark cycle, and that causes a rhythm in internal body temperature. So in a nutshell, our physiology, metabolism, everything is very strongly rhythmic and is tied to the outside world. So what has changed in the last 120 years? What is the fundamental thing that has changed that make us more prone to disease? Definitely our genetic clock hasn't changed, because it's too short of a time to change. What I think is our ancestral rhythms are very different. When our ancestors were hunter-gatherers or farmers, they had 12 good hours of complete darkness, and they could sleep for 9 hours. And then during the daytime, there was plenty of light, there was plenty of physical activity, and the access to food was actually very limited to only 12 hours, because after nightfall, it was dangerous to stay awake or to eat. So people used to eat maybe 2 or maximum 3 meals a day. And after Industrial Revolution, we have electrical lighting that helps us to stay awake late into the night. There is excess food production and easy access to food. And finally, infrastructure development. What does it have to do with health? Infrastructure is the way to move people, product, information, and waste from one place to another place with minimum human physical activity. So that means as infrastructure develops, we are less likely to be physically active. So now our modern rhythm is something like this. We are in dimly lit room like this for 24 hours. We have sufficient access to light. We have very little sleep, very little opportunity for physical activity. And then as long as our eyes are open, our mouth is open. And in fact, we are told that in every 2 to 3 hours we have to eat. So as a result, there is this complete disruption of circadian rhythm that happens that for most of us. And when this disruption happens, for example, if you take a newborn baby or a premature born baby, preemie, and there is strong circadian rhythm disruption, there will be lifelong impaired growth and development. But just imagine just 1 or 2 nights of staying awake late to take care of a loved one or to finish an assignment will cause a lot of inconvenience. For example, these ones. And in fact, this may not be disease, but if somebody has an underlying disease, autoimmune disease or something else, that may flare up. And if it continues for weeks or months, then we get closer and closer to a lot of different diseases. And these are not only restricted to young adults or middle-aged adults, and these diseases keep on going as we get older. And in fact, what you are seeing is the summary of nearly 2,000 publications over the last 25 to 30 years showing how circadian rhythm disruption, either in real life situation, among shift workers, or in clinical control condition, or in animal models, can lead to these diseases. And what is scary is the ones that are in red affect more than 10% of the population. So that means for these diseases, there are at least 30 million people in the US, or if it affects only women, 15 million people on an average that are affected by this disease. And more than 90% of our healthcare costs go towards it. And at the age of retirement, at the age of 65, 85% of adults in this country have 2 or more of this disease. and the cost of living with that disease, one of them, is at least $3,000. So now you can do the math. So what the field of circadian rhythm does is to figure out whether we can train our clock, we can maintain a healthy clock and prevent or reverse our disease, or we can time the drug. And then the third and most emerging aspect is, can we really drug the clock so that with a simple drug we can drive a healthy clock? And that's a little bit futuristic. But at the same time, right now, let's talk about what are these clocks. So just like our brain has a clock that we all experience that make us go to bed at a certain time and make us wake up at another time, almost every organ in our body has its own clock. And the brain clock just tells all these other clocks to be in sync. So brain clock acts almost like a master conductor, and then the other clocks obey the rule. And as a result, every day we have these daily rhythms in sleep, mood, metabolism, and even our gut microbiome also goes through 24 hours rhythms. And the question is, how is this connected to the outside world? So we know that when we go from one place to another, across different time zones, or somebody does shift work for a few days, then they can still re-entrain their internal clock. And that happens because of light going through the eye to the master clock. But this signal, what is that light signal, was very curious. We are very curious about it because there are many blind people who cannot see, but they can reset their clock. So almost 15 years ago, when I was a postdoc, 3 different labs, including mine, we made a big discovery in this field. We discovered that there is a blue light sensing protein that's present in only 5,000 squiggly neurons in each of our human eye, and that's called melanopsin. And this melanopsin protein senses blue light and is directly connected to the master clock in the brain. But there are some interesting properties of this. These light sensing neurons are not that sensitive to light. They sense only blue light, but if it is candlelight or orange light or fireside light, then they cannot actually sense and tell the brain that there is light. So as a result, for thousands of years, when we did not have access to bright light at night, these melanopsin cells were sleeping in the evening. Our brain was getting the signal that it's the evening time, melatonin was rising, the sleep hormone was rising, and it was making us fall asleep, and we were getting a good night of sleep. At the same time, during daytime, as we get out of the bed and go outside, the bright light would activate this melanopsin and would activate all the alerting function of the brain, synchronize the brain clock. It raises alertness and reduces depression. So this was going on for thousands of years. And in the modern days, as we stay indoor with bright lights and bright screens at night, then the blue light from those light sources confuses melanopsin and confuses the brain, and brain cannot figure out when it is evening. So your sleep hormone melatonin doesn't rise, and we have difficulty falling asleep, or we wake up too many times at night, or even in the morning when we wake up, we feel very tired. We have foggy brain during the daytime, and then throughout the day we spend most of our day in dimly lit room like this. That's not bright enough to reset our clock. So as a result, we go from sleepless night and foggy brain during daytime, and if it continues for several weeks and months, then again, scientists have shown that we get closer to many mental diseases. So as a result, there is a new idea that there is a new lighting revolution that essentially says light for vision is not the same as lighting for health. And in fact, a few years ago, The Economist magazine wrote a very provocative article calling light therapeutics. The idea is if light affects our mood, hormones, reproduction, and alertness, depression, then light is a drug. And if we can control lighting, then we can improve health. Then the question is, who should regulate light and who should listen to it? So that discussion is still going on, but at the same time, scientists are still trying to figure out how much light is good for us. And we haven't come to a consensus, but there is a rule of thumb that lighting to treat depression or seasonal affective disorders, winter blues, or ADHD, one should get at least 10,000 lux of light for 15 to 60 minutes. What is 10,000 lux of light? So that is, if you go outside, even without the directly standing under the bright sunlight, if you're in a shaded area, you get 10,000 to 20,000 lux of light. So just going outdoor gives you the best antidepressant in this world, and it's free. We just have to set our foot outside. And then average person, for an average who don't have depression or something, then we need 1,000 lux of light, 500 to 1,000 lux of light for 30 minutes in a day. So that is having your breakfast right next to a window, not even looking at the sun. And just before going to bed, at least dim down your light and have less than 20 lux for 2 to 3 hours before going to bed. That will help us to build up our melatonin level. And we have been working with various national institute, building code, specifiers, for example, ASRE. And at Salk, we also have what we call Academy of Neuroscience for Architecture, where neuroscientists and architects have a joint dialogue to figure out how to incorporate the knowledge from neuroscience into architecture. And our lab also has an iPhone app called My Lux Recorder, which is free, and you can just download and then look around, and then it will show you how much light you have. So it's a very simple app, and you can click and save, so you can go back and see how much light is in which place. And this simple idea has revolutionized so much that now there are nearly 2 billion smartphones and PCs that change their screen color from blue to maybe orange color at around 10 o'clock at night. It's really gratifying to see that this basic science discovery that happened in a little mouse 15 years ago has already made it to 2 billion devices, so that people can become curious about the effect of light. And in fact, there are many other apps and wearables that are coming into the market. At the same time, if we think about light, and if we look at this nighttime image of the US, then you see all these bright spots, and if you zoom in, and then you see this kind of kitchens. So that means we don't stay awake late into the night just staring at reading books or something. We actually have entertainment and food. So then we got curious about what is the effect of food on our circadian clock. And to make a long story short, what we figured out is if food is presented at the wrong time, it just disturbs the entire circuit, and then food takes over all the clocks. So that means as we continue to eat late into the night or randomly eat one day or the other, then it's almost like our body goes through jet lag. Although our brain doesn't feel it, our body feels it. So a very simple experiment that was done 10,000 times or more, we latched onto that experiment to figure out, to find the relevance of this simple idea. So the idea is this: if you take 2 identical sets of mice that are born to the same mom in the same room, fed the same diet, had the same microbiome, we divided them into 2 different groups. One group gets to eat a balanced, healthy diet, the other group gets to eat high-fat diet, high sucrose diet, or any unhealthy diet. Then after a few weeks, we know that the mouse that eats the unhealthy diet becomes fat. And that leads to obesity, diabetes, and all these other diseases. And that's the idea that has been driving biomedical research into metabolic disease for the last several decades. What is interesting is if we look carefully into how these mice eat, mice are nocturnal, they should be eating at night time, but if they have access to yummy food, then they will eat throughout day and night. And that breaks down their rhythms. So the genes that are supposed to turn on, the hormones that are supposed to go up at certain time, or the hormones that are supposed to go down at other time, they don't do that. So it's almost like all the traffic lights in a city being stuck in yellow or orange, then the traffic doesn't flow well. So we thought, what is the impact of food versus timing on mouse health? So this is where the basic science and basic imagination about what might be happening about metabolism comes into play. The idea is very simple. Nutrition science has told us that as long as we keep eating, in the morning when we start our breakfast, then we have the right enzyme, the right hormone, and the right microbiome, and our body is primed to digest that food, take some of that food, and burn carbohydrate to fuel our body, and at the same time store a little bit of fat. And it continues as long as we eat throughout the day. And then after our last bite, the burning sugar part goes down because there is not enough available sugar, and then the fat begins to start burning. So in the last few hours of our overnight fast, our body is actually burning fat and at the same time repairing many organs. So next day when we eat our breakfast, the cycle changes again. So now imagine if we spread this food over 15, 16 hours without changing calories, then our body will not have enough time to switch from sugar burning to fat burning. It will also not have enough time to repair our gut lining and skin. So in the absence of that repair, disease-causing bacteria or even allergy-causing chemicals can enter our body and can even cause more diseases. So with this idea, we thought, well, that means if a mouse eats for 10 hours, then the mouse can have a healthy clock, can burn fat and be healthy, whereas if the same food is given over 15 hours or 24 hours, then the mouse may become unhealthy. So we took two identical set of mice. One group got to eat whenever they wanted the high-fat food. The other group got to eat the same food, but they were trained to eat for 8 hours in the first experiment. And we did this experiment for 18 weeks, and there was a very surprising finding that after 18 weeks, although these two groups of mice ate the same exact calorie from the same identical food every week, one group of mice was obese and then the other group was lean. It was so surprising and against everything else that we have learned in nutrition science that I had to get this experiment done 4 different times by 4 different postdocs. So that's why this paper has 4 co-first authors. And what is interesting is the next experiment that Amandine, who is actually in the audience, sitting in the very back, she did was a very heroic experiment. She actually took this fat mouse and then put them back on 8 hours or 9 hours eating and could reverse this disease. That was the most surprising fact. Although the mouse already had the disease, you can reverse it just by changing what time they eat. And another thing that was most profound is there is no single medicine that we know that can reverse all of this disease, even in a mouse, in 10 weeks. So thus, just this 8 hours or 9 hours eating was most powerful drug that we know so far, if you can call it a drug. So then we thought, oh, well, it's nice and gratifying to cure a lab mouse, but what about humans? So the first pushback we got was, no, humans don't eat like mice. We are very different, we eat 3 meals. We wanted to see whether that's true, so we developed an app called My Circadian Clock. And anybody now can go to this website and sign up for this study. But what we do is we ask people to take a picture of their food, because with the picture we get what, when, and how much people eat. And people love taking pictures of their food, so it is very easy. And we ask them to take pictures for 3 weeks because we know that your weekday and weekend eating patterns are very different. And we put them on a timeline to make it easy for us to see when people eat. And this is what you see every time a calorie-containing picture comes in, or sometimes when they forget, they just write it. Then we put it on a timeline, and if it continues for 3 to 4 weeks, then you can see how regularly or irregularly this person eats. And you can see that there is no rhyme and there is really no pattern to it. And in fact, if we look at the weekday and weekend, they also look very random. And if we combine them, then we can see that it appears as if this person was in San Diego in the weekday and went to New York in weekend because we delay our breakfast time in the weekend. But even if we combine all this data and then put it around the clock, then it looks like this person was eating almost throughout the 24 hours, or at least for 18, 19 hours. This person was not an outlier. He was not a shift worker, and he was actually a 9-to-5 job guy from around here. And in fact, in our first study, we had 156 people, and all of them, nearly all of them, had this same eating pattern. And as expected, we saw that people do eat around noon for their lunch, and then dinner around 7 or 8. But at the same time, they keep continuing munching these small meals throughout nighttime. And then we asked how much calorie is present in each of these pictures, and what we find is the midnight snacks are actually very calorie dense. People are not getting up just to have half an apple or something. They're actually having a big bowl of cereal with milk. So then we ask, okay, so for how many hours people are actually eating? Just going back to mouse, because we know in mice, if they eat 8, 10, or 12 hours, they're healthy. If they cross 12, then they become unhealthy. even if they are given healthy food. What we find is 50% of adults eat for 15 hours or longer. And think about it. If the first calorie starts with a coffee and cream at 6 a.m. in the morning, and the last calorie from your glass of wine or beer is at 9 o'clock at night, that's already 15 hours. And if you do it 2 to 3 times in a week, then that's almost like disrupting the clock and going to East Coast and West Coast a couple of times. And then we asked a very simple question. We know that our body clock is most effective in digesting food in the first half of the day. But by noon, people consume less than 1/4 of their all daily caloric intake. In fact, by evening, we still have 1/3 food to go. And in the evening 3 hours, we consume more food than in the first 8 hours. So that simply tells us that we are actually eating opposite to what our body is designed to do. We even gave our participants the watch that I'm wearing that collects sleeping time, eating time, and then we combine that with the food picture so we can see what time the person wakes up and what time they have their first calorie. And to make a long story short, what we found is within an hour of waking up, people actually nearly 80% of people have their first calorie. And then 2 to 3 hours before going to bed, nearly 50% of people have some calories before going to bed. And we know that these two are unhealthy. So the bottom line is, as I predicted, as long as our eyes are open, our mouth is open. So then the question was, can we take some overweight and obese people who are eating for 14 or 15 hours and then ask them to do only one change? The only one change they have to do in their life is to figure out a 10-hour window and then try to eat whatever they want to eat without changing drastically what they're eating within that 10 hours. So we have done this experiment now quite a few times, and other people around the world have been reproducing this. And the good news is within 10 to 12 weeks, people actually lose a modest amount of body weight. The overall health actually improves, and I'll go over some of those. Then the practical question is, okay, so people ask me, how should I organize my day? And here is the very simple and straightforward answer. The American Society of Sleep Physiologists and all the sleep scientists, they agree on one thing, that we should spend at least 8 hours every night in bed. So that includes if you're reading something or anything else, 8 hours in bed. So if you go to bed at 10 o'clock, wake up at 6, then after we wake up, at least for an hour, our hormones are going through change of guard. So the night hormones are going down and the day hormones are going up. So it's kind of not very healthy to eat something when these hormones are changing. So try to avoid food for at least an hour after waking up. And then if you are really brave and you want to start right away, then you can start an 8-hour window and stop eating at 4 o'clock. Or what we advise to most of our participants, actually try to select a 10 hours window because that's relatively easier to adapt. Some people go up to 11, just like me. I kind of sleep towards 11 hours, but never beyond 12 hours. So now you have 4 different choices, 8, 10, 11, 12, or even you can do 9. And then give yourself 2 to 3 hours without food and also without bright light before going to bed. So that makes it your full circadian day. Then what about light and exercise? We know that exercise has undisputable benefit on health. So at least 30 minutes of physical activity, and if you can do it even during daytime, walking in under not midday sun, but even with some daylight, that's good enough. So that's what we aim for among our participants. But then the big question comes, what about coffee? So we say that you can have coffee from your start time until about, say, lunch or maybe 2 o'clock, but not beyond that, because coffee has a half-life of around 6 hours for most of us. So that means if you drink a cup of coffee now, then your body still has half a cup of coffee 6 hours from now. So to have a good night's sleep, avoid coffee from 2 o'clock onwards. But I think most people are worried about or ask us, what about coffee here? Okay. So we have three answers. One is it's just about any food that we eat, a gut has to digest it and send it to the liver, and the liver sends it out, and that's how coffee gets to your brain. So when all this process happens, it's almost like trying to knock on the door of a sleepy person. Even if you knock slowly, the person is waking up. So if you want to do a clean theory, then coffee may not be okay, but life gets into the way. So if you have to keep your job by having coffee so that you can get to your job, have it. Second is safety. In the morning, 1/3 of drivers are sleep deprived, they are driving sleepy. So it's better to be caffeinated than to drive sleepy. And then the third one is if you cannot live without it, we don't want to take the last joy of life from your life. Then the second thing that we are often asked is, well, I want to do 8 hours, and how can I time it? As I said, yes, you can start from 1 hour after waking up, and then you can also sleep, say, 7 hours. But some people want to start at 10 o'clock in the morning, or some people even skip their breakfast and go straight to lunch. And we call it the early theory or the late theory. And the bottom line is, all the studies that are coming out, they're showing that any 8 to 10 hours time restriction is always better than eating randomly. But if you want to have much better benefit, if you want to go 100%, then try to do an early theory. So that may be the ideal, but at the same time, even if somebody is doing this late theory, time restricted eating, that will still give us a lot of benefit. Almost 80 to 90% of benefits are still there, except for a few things. One is what we're finding slowly is maybe the heart health, or maybe people who have mild predisposition to diabetes, it may be slightly better if they adopt a early theory. So now many of you might ask, okay, so what can you do now? So we still have the mycircadianclock.org website where anyone from anywhere in the world can sign up. It's a IRB approved study, so that means all your information is very secure under a secure server, and people do get feedback, and it's a guided study for almost 12 to 14 weeks, so you can see what is your rhythm, and you can try to adopt 8, 10 or 12 hours and see what benefits you'll see. So then the question is, how is this so important? Means just eating 8, 10 hours, is that it? So what we really see is this. After people start doing this time-restricted eating, their nutrition quantity goes down, of course, because the late night snacks and then the wine and beer, those are going down. So you are losing some calories, you are reducing some calories, and in fact, you are reducing some calories that are unhealthy. So your nutrition quality goes up. And for some reason, we do not understand correctly, but that might be something to do with gut and other physiology. When people do this time-restricted eating, they get into deeper sleep at night. So they don't wake up that many times, so their sleep quality goes up. It happens 2 to 4 weeks after starting this time-restricted eating. And then they also have much easy to get into sleep. So sleep onset is much better because you're also avoiding light as part of it. And then your sleep duration may improve for some of us. So sleep improves, nutrition quality improves. Then what happens? So we see reduced inflammation. So those who have little joint pain, that seems to go down after 6 to 8 weeks. In some cases, it takes up to 10 weeks. So once your joint pain goes down, then you can do better physical activity. Instead of taking the elevator, you can actually start to take the stairs. And then since everything is so timed, you actually can set aside a chunk of time for your physical activity. And then another surprising thing that we find is people who do 8 to 10 hours time restricted eating, they see a profound improvement in their endurance. So those of you who are into biking or staying on treadmill, then you'll see that you are less tired at the end of your biking or treadmill. So then going back to this particular chart, because what matters at the end of the day is this chart. Can we reduce some of the disease burdens? Because even if we delay the onset of one single disease for 1 year, that's $2,000 to $3,000 of saving in productivity loss and also in healthcare cost. And if we can prevent that in 1 million people for 1 year, so that's a $2 billion saving. So We and others around the world are now doing many controlled clinical studies where we are measuring many different blood parameters and also different things invasively and non-invasively. And what is really gratifying to see is some of these diseases that you see, for example, obesity, pre-diabetes or type 2 diabetes, this is acid reflux. Some of these we are beginning to see are actually prevented or in many cases can be reversed by sticking to this time-restricted eating for at least few weeks, 10 to 12 weeks. And then the field is getting really rich almost in every month. There are new papers coming out in very high-profile journals. So for general public and even for many of the scientists in the field, it's really hard to keep up with the literature. So that's why a few years ago, some of my colleagues at Salk Institute inspired me to write this book. And I must say that all of this was actually possible, this research was possible because I was in Salk. It would be impossible to do somewhere else because at Salk Institute, many donors, they gave us unrestricted fund. And for example, for all of these experiments that I described, I had applied to federal agencies 18 times and I did not get funding. Only on my 19th trial, finally last year, I got funded. And until that time, all of this was done with unrestricted gifts and targeted gifts from donors like you. So the book is divided into three major parts. The first part deals with the circadian clock, and it begins with the idea that we are all shift workers. When you think of circadian rhythm disruption, you might be thinking the guy who works in the assembly plant or the firefighter or the ambulance driver, they are the shift workers, their clock is disrupted. But in fact, in this chapter, I go into saying what is considered a circadian rhythm disruption that causes disease. And in fact, almost all of us go through this kind of disruption at least few years in our life. Whether you're a mom, whether you're a student, for example, in my lab, for the last 2 weeks, almost everybody in our lab, 10 of us, we are going through 6 to 7 hours of, actually 9 hours of work in the middle of the night every 3 or 4 days. And we are going through this. And then the second chapter is how circadian rhythm works. So I go a little bit into the molecular mechanism and what are the cells, which cells have clock and how they work. And then the third one is track and test. Is your circadian rhythm okay? So these are very simple questions and then few other ideas. Then part 2 goes into a circadian code for best night's sleep, because sleep is one foundation of health. And then nutrition to lose some weight and improve your health, and then to improve your learning and working of brain health. And that chapter goes into lighting and how to manage light. Then finally, how to exercise so that your circadian clock is in sync. And then I give some tips about lighting. Then finally is optimizing circadian health. What happens or how can you manage your clock if you have a gut disease or digestive concern? And circadian code for addressing metabolic disease. This is the crux of the book because obesity, diabetes, and heart disease affect more than 70% of adults in this, older adults in this country. And we can reverse or prevent many of them. And then finally, enhancing the immune system and treating cancer, because 40% of us at one point in our life will be diagnosed with cancer. And if we can reduce our inflammation right now, then we can delay or we can even prevent. Second, during cancer treatment, the new studies are showing that if we time the drug to the right time, then we can improve efficacy and we can get cure. Then the third, even after cancer treatment, if we stay on time-restricted eating, then we can reduce the risk of getting relapse. And that's now beginning to show up because epidemiological studies are showing that women with breast cancer, if they eat for only 11 hours, then their chance of getting another bout of breast cancer goes down significantly. And those studies are being repeated throughout the world. And in fact, now we are seeing new data on prostate cancer. And then finally, how to optimize circadian code for preventing dementia and improving brain health. And finally, a perfect circadian day where I give a few examples. And in fact, this book ends with somebody who has been living a very healthy, long life and has been very productive in his life. And he's here, Roger Guemin, who is a Nobel laureate, who is a faculty at Salk, still drives his car every day, and his lifestyle goes with a clockwork. He actually, we interviewed him a few years ago, and the book ends with his interview. So with that, I'll leave you with this very simple idea that our optimum health is driven by having a strong clock. And when we have erratic lifestyle, then that disrupts this cogs in this wheel, and we get all this disease. And it's almost like taking 10 different cars and going off-roading. It's not that all 10 different cars will have the same problem after 2 miles. So the same thing happens. Depending on our gene, one may get heart disease, one may get cancer. But the bottom line is, if we have a better circadian lifestyle, we can prevent or reverse many of them. And thank you.
Well, I've heard Satchin many times, and I always learn something new. And it's wonderful to have somebody doing something that we can actually apply to our lives. And it's positive and hopeful, and we need a lot more of that in today's world. Well, we have about 10 to 15 minutes for questions. I know we won't get to everybody today. We've been live streaming on Facebook, so we've got questions from the audience and potentially online. My colleague Jane and I will be wandering around with microphones. So Jane, there's a question right here, the gentleman in the hat. And then afterwards, before you ask your question, we have a book signing with Satchin. He will be at a table in the reception. So please don't come down here to try to ask him questions, because he has lots of people who are going to want his signature. So we will have him in the foyer with food, reception, all of you, books. And if you haven't gotten them, he's had so many write-ups in the press. We have one printout from the New York Times, but just Google his name if you want to see what's out there. It's pretty impressive. So go ahead with the first question.
Thank you very much for such a comprehensive presentation. I'm very interested in your comments and ideas, and maybe past experiments or future ones, regarding the factor of aging with all the complex variation that you addressed.
Yeah, so right now, when we talk about aging, most of us have diseases of the aging. So our immune system deteriorates, our motor coordination deteriorates, so that we cannot walk properly, we cannot run properly. So those are the signs of aging. And this time-restricted eating can delay or even reverse some of those signs. So we think that this will ultimately increase the healthy lifespan, so that we'll live a few years longer. In fact, just the first experiment in rodents, little mice, just came out last week from National Institute of Aging, showing that mice that eat for 12 to 13 hours, even 13 hours, they live longer than mice that ate the same number of calories every single day in their entire life, but the first group was eating randomly, and then this 12 to 13 hours group lived longer. They did not live as long as some of the old caloric restriction study, where you have to reduce calorie by 30-40% every single day. But it's very amazing to see that without counting calories, mice could live longer and healthier.
We're going to actually take a Facebook live stream right now from Emily. She's actually in Satchin's lab, and she's been helping out.
In fact, Emily will be around after the talk, so if you have questions, she's the one who answers more questions in my lab than I do.
All right, so we have a question from John on Facebook asking if children should eat within a 10-hour eating window as well.
Okay. Okay. So let's answer it slightly differently. I'll actually pose the question to you. So according to sleep physiologists and pediatrists, children should be getting around 9 to 10 hours of sleep. When I'm talking about children, I'm talking about children up to the age of, say, 10. Okay, so if they're sleeping for 9 hours, and they should not be eating for couple of hours before going to bed, that's already 11 hours, because even among children, not having food will help them to go to sleep better. And then after they wake up, they will take half an hour to an hour to get ready before they go to have their breakfast. So you can do the math. Even children can actually eat for 12 hours. So that's why I say, if you're thinking about 10 to 12 hours, at least 12 hours, a 5-year-old to a 100-year-old can try to eat within 12 hours. Sleep for children 9 hours, for adults say 7 to 8 hours, and this is normal. Yes.
I noticed Alzheimer's on your list of diseases that could be impacted by a circadian lifestyle, but not Parkinson's. I'm curious why.
So we haven't actually looked carefully because it's such a new area of study. Hopefully, what we expect is in few years, people will start experiments with mouse models of this disease, and then we'll see results. So far, we have seen from Huntington's disease model, and mice who have the same mutation that causes Huntington disease in humans, if they eat within 8 hours, then the disease severity is reduced, they sleep much better, and their physical performance and activity is way much better. So that initial experiment result from Huntington's disease is giving us hope that hopefully we can replicate this in few other disease models. Thank you.
A simple
Sure.
question.
Right here. In the front.
In the front? Okay, this is a simple question. What does water intake?
Oh, yeah.
Should you limit water during the rest period?
Yeah, so actually I forgot to say, so you can drink plenty of water outside this eating window, and in fact many of the medications are also fine, so you should consult your physician about medications, but most medications are fine, unless you're eating those gummy bear vitamins, 5 of them in the middle of the night, so you got to be careful about that. Oh, here.
This is fantastic work. I've been studying this material for about 7 years now, since I had insomnia back in 2011. It's phenomenal. I know that a lot of my studies, the material that I've learned about circadian rhythm, are coming from the Ayurvedic and Indian culture, and I'm wondering what influence that had off of your studies and the work that you're coming up with.
Actually, some of the influence came from my research in plants. Because in plants it's very simple, straightforward experiment. You take a little plant and you give them light for 8 hours, which is like food, then the plant will take a long time before it produces flower and fruit and dies. Such a long life. Whereas you take a plant and expose it to 14 to 16 hours of light, that's food, then the plant will flower and fruit earlier and dies. So that was kind of in the back of my mind, that if you eat for less number of hours, then you can live longer. Thank you. Okay.
In military personnel, especially special operations, they go through selection and assessment in numerous schools in which they're put through circadian disruption, energy deprivation over and over and over again over the course of their entire career. And would this suggest that maybe we are aging them early? I can tell you from having studied them, they'll have significant endocrine dysfunction. But if you look at their values, oftentimes the lipids, hemoglobin A1C are normal before and after these schools. So what would you say this has in terms of impact for something like that?
Well, we're actually starting to study not really military personnel, but San Diego firefighters. And they also go through the same lifestyle. And in fact, Emily bravely went and tried to experience what a typical San Diego firefighter goes through. And she did quite a few 24 hours ride along. And just imagine getting woken up 10 to 12 times every night at random time. And you have to go through every single wake up and do the run and come back. And after 1 or 2 rides, she said, I don't understand how these people are still alive. But what we know from firefighters is they say that when they retire and within 3 months or 4 months, they come back and they feel like they have become 10 years younger. Just not having that disturbance is so much. And a very simple thing, when you look at any news about a 100-year-old, you'll never find a military personnel, a firefighter, a pilot, or very rarely even a scientist living up to 100 years. And one of the common theme about centenarians is they live a very simple lifestyle and they eat everything within set period and they do enough exercise and are exposed to light. So at the same time, we're interested in these extreme ones who go through repeated circadian rhythm disruption and yet they're healthy because we want their DNA to study. And if you know somebody, it'll be, I'm serious, we would like to study them.
When people are eating, their mouths are open, and have you found any correlation between improved nasal breathing and better airway function in your research, or are you looking at that?
Yeah, so this is so new because our first human study was only 3 years ago. And so these are some of the conditions we are looking at now. We just got funding from National Institute of Health, and literally the funding letter came 2 days ago. So that means we'll start recruiting maybe December, January, and one of the questionnaires and one of the assessment will be OSA, obstructive sleep apnea. So we'll get to that.
Okay, with Jane.
Yes, thank you, Dr. Panda. A great presentation. You did one back a number of years in the Rancho Santa Fe Rotary Club.
Yeah.
And people still talk about it.
Thank you.
My question relates to coffee, and I assume that relates to caffeine. We have a lot of other drinks that have caffeine, so is the limitation the same on those?
Yeah, so I'm asked, we actually spend 80% of our questions are about caffeine and non-calorie containing drinks. So when it comes to, say, sodas that have sugar substitute, we know that that sugar substitute does affect our gut microbiome, so there are many other reasons why to avoid them. But few drinks, for example, carbonated soda, just seltzer water or sparkling water is perfectly fine. And in fact, you can put a little piece of lime and act as if you're having gin and tonic or vodka. And many of us do that, and so it's fine. About other drinks, being a scientist, I always want to go back and do the experiment, at least in mouse, and it's very hard to give them this kind of drinks. But what we tend to do is try to do as much as you can with calorie-containing food within 8 to 10 or maximum even 12 hours. And then outside, hot water, cold water, sparkling water is fine.
Okay, this is the last question, and then he will be having to go.
Thank you for an excellent talk. I'm wondering what happens to animals that are naturally nocturnal feeders, like owls. Do they reset a different sort of circadian rhythm?
Yeah, so actually owls are extremely interesting because some of the owls go back and forth between nocturnal and diurnal, the owls that live in northern latitude, and so the field of circadian rhythm is very wide and diverse because we also some of us study the switching between nocturnal and diurnality, and for birds, even migration from one place to another. So we don't understand too much of it because we have a lot of observation. We don't understand the molecular mechanism that helps us switch. And so before we end, those of you who have books, of course, I'll sign, and those who have already bought, and if you like it, then please go to Amazon or wherever you bought the book and then leave a rating. That will help other people to appreciate the work and spread the word.
Thank you, Dr.
Thank you. Thank you.